Okay. Today we are going to continue with the sessions. So as I discussed in the previous classes, okay. So are you guys audible to me? Okay. I was discussing with the HDFS user commands, and I told you some of the basic concepts like HDFC name node. What is the meaning of HDFC name node federations? Okay. So, and many more concepts we have discussed, like checkpoint, backups, snapshots, okay, and some of the basic SDFC user commands. We will discuss some of the basic SDFC user commands, okay, and we are going to discuss today, and we are going to conclude our first module of this SDFS. Okay, that is nothing but MapReduce model. Okay, so already you have heard when you are studying about cloud computing also, if you remember we have studied about MapReduce. Okay, so the overall concept of SDFS is totally dependent on map and reduce. Okay, that's a very important concept, map and reduce. So today we are going to cover that concept, MapReduce model. What is this MapReduce model? As you know, MapReduce is a very powerful tool because it is going to help us in today's world for many applications, and it is most commonly used kind of tool. Okay, so it is going to work in two stages. One is called as a mapping stage, and one more is called as a reducing stage. What is this mapping stage? Mapping stage is nothing but it is going to act like a filter. Okay, or you people are even call it like a sorting process. The best example here the author gives is nothing but if you want to count how many times the name Ram appears in a novel. Okay, we just consider an example where I'm having a novel. Okay, in that novel, I'm going to have a repeated word of a person. There is nothing but called as a Ram. Ram, I can say. Okay. So what we can do is we are going to call 20 friends. Okay. For example, now we are having 26 participations. Okay, into the video. I'm going to call 20 of you and tell you to. I'm going to divide the sections of the book, and I'm going to tell you to find how many times the Ram appears in your section. Okay, like this, everybody is going to take their own time, and they are going to count the number of times the RAM appears in your section. And that is nothing but I'm going to call it as a map stage. I'm going to mapping you the work. That work is in general for your example is nothing but you need to find out how many times the RAM appears in your section. That is nothing but called as a mapping stage. And next phase is nothing but called as the reduction phase, or I'm going to call it as a reduce phase. This is how the map and reduce works. Now I'm going to mix everything, means I'm going to take all the count from each and every person, and I'm going to sum the total, and I'm going to find that the total number. That is nothing but the best example of map and reduce will be. Okay, so first what we are going to do, we are going to find the divide the sections, and you are going to give the number of sections that you people need to do, and in that you need to find the example of RAM. Okay, so if you are going to count the number of times the RAM appears, then we are going to do the sum of the all the count, then that is going to become the total. That is nothing but called as reduce. So we'll see in detail, but this process is going to have the series of steps. Okay, so the first step is nothing but splits the input. Okay, so for example here my input is RAM. Okay, now I'm going to split the inputs, means nothing but I am doing a mapping phase. Okay, this is a part of the mapping phase where in the HDFS distributed, we know that there will be a replica of the data. Okay, over many servers, same data is going to be available in many servers. Okay, so what I'm going to do is you people know how the name node is going to allocate the block to the data node. Okay, it is not going to use any logic, it is just going to use nothing but the size. And you know what is the size of the block should be in order to allocate from name node to data node. That is nothing but 64 MB. Okay, so thus what people do is if I am going to have a file of 500 MB, then I'm going to break each and every block of a 64 size. That is nothing but I'm going to get 8 blocks. That's an example. Okay, this is how the input splits is going to work. Okay, So these 8 blocks are returned to the different machines in the cluster. Then the data are also replicated on multiple machines. Okay, this is nothing but called as input splits. This is how I'm going to split the input. Okay, if I'm going to have a 500 MB of a file, and you know what's the size, minimum size of the block should be, it should be of 64 MB. Then I'm going to divide each and every 64 MB. Then obviously I'm going to get the 8 blocks, and that 8 blocks is nothing but going to be circulated. And if you remember the condition that if I am having more than 8 data nodes, then the factor of replication will be 3. So that is what I am replicating the data typically for 3 machines. That is nothing but 3 times the data is going to be replicated. Can you guys see that? Okay, because why? Because I am dividing into 8 blocks. 8 blocks may consist of 8 data nodes. 8 data nodes, when I are having, it is nothing but more than 8 or equal to 8, then we are going to consider that as a replication of 3 machines. Okay, this is how the input splits works. This is the first phase of your MapReduce parallel data flow. Okay, this is how the MapReduce works. Okay, basically nowadays even your Google, okay, everybody is using the MapReduce concept. Okay, wherever you go, people are going to come across the MapReduce concept. Okay, so when I say next step, there is nothing but map step. Okay, so what we are going to do with the map step? The best thing is nothing but here the mapping process in which the parallel nature of Hadoops comes into play. Okay, if I am having a large amount of data, then there may be a more than one mapper. Are you understanding what I'm saying? If I'm having just not a 64 MB of a data or 500 MB of a data, I'm having GBs of the data. Okay, at that time, obviously, I'm going to consist of more than one mapper. People just seen the example of a mapper that is nothing but called as a yarn. Yarn is also a kind of a mapper. Okay, similarly, I can find any number of mappers like this. So when I'm having a more amount of a data that is in terms of a GB, I'm going to have more than one mapper. Okay, so what happens? This mapper starts to allocate the data, but to the bad fate, if the node is busy, okay, which node you want to, data node you want to allocate the data from the name node. If that node name node is sorry, data node is busy, then the data, what the mapper will do, the mapper is going to select the nearest data node. Okay, so that if that data node is available, then it can switch from that data node to the dedicated data node. That is what the process is. Okay, so this is how the things goes. If all the data nodes are busy, okay, I don't have any data node only, the last choice is any node in the cluster that has access to Hadoop distributed file system. This is how the priority comes. Okay, first name node is going to decide to which node the data should go. Okay, that is a very important thing. For our bad fate, if that data node is busy, then what is going to happen? Then the name node again see which is the nearest node to the data node. Okay, that data node it is going to be selected. If again that data node is also busy, then what is the next thing? The next last choice is nothing but any node in the data node, which is going to be selected. Okay, so the third step is nothing but called as combiner step. Basically, the combiner stage is optional. Okay, what is the meaning of a combiner step? It is going to reduce the number of steps in the MapReduce process. Okay, that is nothing but called as optimization. It is going to convert the given data into some key value. Okay, pairs of key values. That is nothing but combined step works, and it is optional. Purely, it is an optional. The next thing is called as shuffle step. Okay, what happens before the parallel reduction stage can complete? Okay, a similar keys must be combined and counted by the same reducer. As I told you, the best example before starting this class is nothing but if you are having a novel and you are searching for the keyword called as Ram in the novel, and now you cannot say Ram appeared once, Ram appeared twice, Ram appeared thrice, Ram appeared four. People count everything and you are going to take the number. Ram is there for 25 times. This is how the shuffle step works. Okay, so it is going to collect the key value pairs and shuffle to the same reducer process. Okay, if only one reducer is means there is no more data. If there is only one data is there, then they are going to use single reducers. If more than one data is there, they are going to use multiple reducers. This is how the shuffle step works. And again, the last step is nothing but reduce step. Again, it's an optional step. Okay, it's a purely an optional step. And actually, the reduction in this stage, the data reduction is performed as per the program's designs. Okay, so we'll see with this example in this diagram. Can you guys see this diagram? See here, my input is C spot run. That's a one line of statement. Run spot run. It's a second line of statement. See the cat. It's a third line of statement. Now what happens? You're after input. Okay. The first step is input. Input is split. Okay, based on the blocks. It may be of size 64 MB. If the total size of the file is 500 MB, it is going to be breakdown into 64 MB and total 8 number of blocks. But here he has taken a simple example. He split it into three statements: C spot run spot run, and C the cat. Okay, this is a split stage. Then after split stage, the second stage is map. Now they are started to map. This map C is one word, spot is one word, run is one word. Again, run is one word, spot is one word, run is one word, C is one word, run, da is one word, and cat is one word. Okay, the map stage is finished. Now the shuffle stage comes. If people remember, combiner step is optional. Okay, combiner steps is optional. It's left to the designer who is going to design. Okay, combiner steps is optional. Then what happens? Shuffle step comes. The shuffle. See, people can see now the similar words, the key way, the value of key pair. Okay, this is a key pair now. Key pair. People call it as a key pair. Now C is a key pair. Spot is a key pair. Run is a key pair. Okay. So more than once the key pair arrives. Okay, more than once the key pair arrives. People can see in the shuffle stage I required more than one reducer. Okay, if not, single reducer. Like there is the and cat appears only once, so I'm using single reducers. So now what happens? I'm taking the count. This become a key pair value C1. Spot is going to become a key pair value. Run is going to become a key pair value. Okay. So now what I'm going to see is I'm taking the count. C is appeared twice. Spot is appeared twice. Run is appeared thrice. Da is appears once, and cat is appears. Now the reduced state and output is, people can see, I have mapped and I have reduced the time. Okay, so this is how the things goes in case of map and reduce. Now C is twice, spot is twice, run is thrice, die is once, and cat is once. This is how whenever a line of input is going to be given to the map reducer, it is going to work like. Okay, similar to the best example is finding the RAM in the novel. Okay, you are going to map for 20 friends. Similarly, you are going to take the data blocks and you are going to map it. Okay, once the mapping is done, then you are going to start reduction, and all this reduced is combined, and that is nothing but your output. This is how the map and reduce is going to work. Okay, so as I told you guys, did you install the Hadoop cluster? That is very, very important to work the Hadoop distributed file system. Okay, simple. There is a simple program where I am mapping the RAM to a particular token. Okay, token is a variable here. Okay, I'm taking an input through a line. Okay, and I'm mapping the RAM and Sita to a token, and I'm taking the inputs. Okay, that is how the mapper works. And similar to this, I'm taking the count reducer. Okay, how many times the RAM has appeared, how many times the Sita is appeared in your particular novel. Okay, so this is a reducer script and this is a mapper script. I request you guys kindly install the Hadoop cluster and try to work on these things. Okay, so how to work on this? To compile and run the program from the command line, you need to perform following. First, you need to create a local word count class directory. Okay, so then you can compile the word count using this Java C. Okay, Java compiler. This will be all the packages present in your Hadoop cluster. Okay, then you can run even create using a Java file, and then you can run the program. Okay, to run the example, people create your input directory in HDFS and place a text file in the new directory, because it is purely a word count file. Okay, I need to have a novel. Novel in the sense means I should have a line of count, like Ram and Sita should appear in my text. Then only I can able to find the count of them. Okay, so this is how the things goes. Okay, and debugging MapReduce. The best advice for debugging parallel MapReduce application is this, because if it's a distributed system, it is very hard. You cannot run at a single instance of a time. You cannot create a distributed file system, distributed Hadoop cluster, and you can run that program. The simple approach is nothing but create a simple system, means only one Hadoop cluster, and give the data set to that same simple Hadoop cluster, and then you people run the program first. Okay. So, and very, very important is call logo. Okay, logo logs. People call it as logs. Okay. So you should always keep track about the application logs. Okay. So what are the jobs that can be managed using mapped job commands is nothing but kill, list, and status. Okay. So these are the three important status of the jobs. Okay. Coming back to Hadoop log management, the MapReduce logs provides a comprehensive listing of both mapper and reducers. Okay, so it is keep on means the actual log output consists of three things. One is called as STD out, standard output, okay, standard error, and system logs. These are the three things that every log management system consists of. Okay, so based on these three things only, everything is going to be assigned. Now you are going to get a standard output using STD out. Okay, you are going to get an error. There is nothing but using standing error, a standard error, and you are going to get a system logs. This is how the things goes. Okay, so coming back, this is an example they are showing that how they are run the activities. Okay, fine. Okay, okay. Screen sharing. Okay, got it. Is recording stopped? No, okay, fine. Yeah, this is an example where you are going to display the log type. Okay, log means what all the things you are going to do while you are running the program. It is nothing but log. Okay, people can see your mobile. You are going to have a call log. Okay, today's little internet problem. Kindly adjust. Okay, so call log. In a similar way, here you are going to have a Hadoop log system. Please kindly install a Hadoop cluster. Okay, and work on this kind of things. Then only you can understand better. Okay, so even you can have a manually enable log aggregation, means people can run this commands like SDFS, DFS, okay, Hadoop distributed file systems. Okay, in order to create a directory, mkdir, like yarn scheduler people can use. Okay, so these are the very some basics aggregations. Okay, when you are going to have a web interfaces, yes, you can use even just this is an example of a web interface log. Okay, can you guys see this? This is an example of a web interface is like because you are keeping the log track over the browser. Okay, so like this, people even can have a web interfaces log. The most convenient way to use log is nothing but YARN resource manager and using a web interface. Okay, and again, if people know the content of the content is nothing but you people find three things: std out, std error, and sys log system log. They are all displayed on a single page. If you run this, you people will understand it better. Okay, so people find all kind of people can see if it is very clear. People can see std out is here, sy log is here, and if any error with respect to log, it will come std ere. Okay, std error. Okay, err. Okay, so this is how the things goes. And when I say command line log view language means here what I'm going to happen is people can run a command like this. This is an option to yarn logs. Okay, when you enter into the yarn scheduler, people can directly now people can see how you are going to enter into the Python editor. In the same way, when you are going to enter into the yarn editor, you will just type yarn space logs, which will retrieve the logs for complete yarn applications. Okay, if I want to find the what I can say log for the app owner, then I need to enter the app owner ID. If I want to find the log for the container, then I need to have a container ID. If you want to find the log with respect to node address, I should have a node address. This is how I can individually find, or just in general, if I want to find the logs, I can say directly yarn underscore logs. Okay, so this is how the things goes. And after, for example, after running the word count example program, you can finish. Okay, this is how the things goes, guys. Okay, so this is all about your web interfaces using yarn applications, and this is about Hadoop log management systems. Okay, so debugging. I think if people are understanding some, at least if people take something to this from the today's class. Very important thing is MapReduce. Very important type. I can even ask this in the internals. Even it is important questions in the exam. People have SDFS snapshots. Okay, name node federations, name node high availability. You know, more than one node will be there. Okay, the two name node. We are going to call it as a name node high availability. Rack awareness. Okay, that's important. SDFS safe mode. Replication, how it is going to replicate the data, and the components. Very important components. Three components. Okay, name node, data node, and secondary node. Okay, so these are all the things we have studied in this first module. Okay, so with this, we are going to complete our first module, and in the next classes, we are going to start with our second module. Basically, here we are going to study about the languages. Okay, So these are the we are going to concentrate mainly on pig. Okay, and how data types are going to be used with respect to that of the pig. This all the things we are going to use in the upcoming classes. Okay, once I schedule the class, I'm going to send you the information. Okay, those who are interested, you people can join the classes and learn about these things. They are very important. Okay, all these languages are nothing but Hadoop based languages. You're having Scoop, Pig, HBase, Hive, Flume, OZ. Okay, so all these languages are very important. Is the second chapter is purely, okay, you people know second chapter is purely a Hadoop tools. Okay, so here I am having the lecture plan. People can see essential Hadoop tools. Okay, in this we are going to study about introduction to Pig, different kinds of data types used in the Pig, installation of Pig, and Apache Scoop. Just I told you what is a Flume. Okay, what is Hive, why Yarn. Okay, components of Yarn, basic Hadoop Yarn administration. There was some internet connectivity. Sorry for the disturbance. Okay, so we'll continue the next module in the next coming class. Okay, thank you guys. Thank you for the class today. Okay, bye. See you tomorrow.